identifying weaknesses in the training data set. So that basically excludes a lot of the neural network stuff. That excludes random forests, which make it much harder to really think about what your biases are. And so the problem is if you run a random forest on your classification of variable versus non-variable stars, you get a set of variable stars, you get a set of non-variable stars. You now say, I'm going to just build a model for my variable stars about why my populations of periods looks like this. If you got these selections from a machine learning algorithm, all the uncertainty in that machine learning procedure, all the cases where the machine learning got it wrong, that information is no longer contained in that data set because you assume you have a sort of true population of
about why is that flashy? Or the bands?
I don't think that's right.
I
mean, if you want to have a precise measurement, then fine. But if you want to have an accurate, meaningful measurement, then you have no constraints on that.
So I think Boris just wrote a paper on that,
That's
right?
right, yeah.
So there's Boris Leistad in New York just wrote a big paper on why generative models, why not using machine learning, but a model that can actually generate the data does much better at doing cosmological inference.
In terms of bias.
In terms of bias, yeah, than machine learning. Because the problem is you do your photometric redshifts and you run them through your random forest or anything and you get a measurement out. But you don't know anything about what that measurement actually, what the biases in that measurement is. You don't really have an uncertainty for that measurement. You can't propagate any of that through.
So one example that I've run across is in trying to detect supernova by doing image subtractions. It turns out it's really hard to do subtractions well enough to get no junk. So you just end up finding mostly junk. And so that's a problem where we don't actually care about being 100% complete. We don't care about understanding the junk perfectly. And so we've used random forests to basically...
But let's say you want to learn the density distribution of stars in the Milky Way. You now don't know what the machine learning algorithm is doing to your selection function unless you model that as well. So it's not really, as soon as you want to draw physical conclusions from the population that you end up with, it's not going to be a good way to...
So you're saying even that, in the supernovae detection, you're saying you're still introducing kind of a hard to quantify bias.
Yeah. So I think part of it is, I think this point about not being able to do anything else is not a bad point.
Mm-hmm.
I think there are many cases where doing the proper thing that would take into account everything might just be computationally unfeasible.
Okay.
And so then you use machine learning to say, okay, this is actually something I can do. The important thing is that you need to remember that these biases are in there and that you can't use the results as a ground truth. And it shouldn't be, I know, when I started with machine learning, it was like a giant buffet of awesome things that I could try and do.
And it is a lot of fun.
And it is a lot of fun, but most of those are actually not that useful for science, at least not as a first choice. And so that's kind of something to be aware of.
Thank you.
Cool.
Okay.
Okay, so now with that in mind, we're now going to play with some machine learning applications. So there's a repository under my GitHub, which is ADRN, and it's pyastro17-tutorials. And if you could navigate there, so it's github.com/ADRN/this. And we do have post-its. We could actually do post-its. You take one of each. Okay, if you already have them, put a green post-it as a flag on your. Take one. Put a green post-it on the back of your laptop as a flag if you're at the state where you're at this page, or you've cloned the repository. But we'll go through that. So we're going to do something with Git, and then we're going to do something with Jupyter Notebook. So I hope none of you wanted to go to the Git or Jupyter Notebook sessions that are also happening in parallel right now.